All right, so here's another equation for us to solve. We're going to find the t-values that satisfy this equation. And like I said, we're using trig identities to help us solve these equations. Now, whenever I see any equation that involves trig functions, it's a lot nicer if I have the sign and it matches the sign, but the arguments of the signs are different. And so the first thing I really want to try to do is try to change them so that they both have the same argument, right? The input to the sign is the same for everything. That just makes it easier to solve. So that's the first thing I'm going to try to do. And what I'm going to do is look back at the first page of this lecture has a bunch of different identities that I can choose from. So I might look back at that and say, okay, what can I use? Well, I have double angle formulas. So for this particular expression here, the sine of 2t, I'm going to use a double angle identity. Identity. Okay, because I've got sine of 2 theta, or 2t in this case. Now for this sine function, what I have is those phase shift identities. All right, phase shift identities. So I can use that to change that one. So what do I get when I do that? If I replace the sine of 2t with the double angle identity for sine, what I get is 2 sine of t cosine of t. And then over here, I've still got the square root of 2, but I'm going to replace the sine of t plus pi over 2 with the phase shift identity. Now remember that if I take the sine function and shift it to the left by 90 degrees, what I've got is essentially the cosine function. So I can replace the sine of t plus pi over 2 with cosine of t. So now I have trig functions now, but now they're all in terms of t, which is just going to make it easier, okay, if they have the same argument, if the input to the trig functions is the same. All right. Now, what can I do with this? Now I have sine and cosine. So what I'm going to do is I'm going to take this sine of t cosine of t, and I'm going to subtract the square root of 2 cosine of t from both sides. So minus square root 2 cosine of t equals 0. Okay, so I can see that I've got sine and cosine. So now I can factor out the cosine, right? I can factor out this cosine of t because I have a common factor of cosine t, and I can then I'm left with, inside the parentheses, I'll have sine of t minus the square root of 2 equals 0. Okay, so now I have two factors, and the product of those two factors is equal to 0. So that means that one of the two factors has to be 0 in order for this to be true. So let's look at what the t-values, let's look for the t-values that make cosine equal to 0. And we can also look at the t-values that make sine of t minus the square root of 2 equal to 0. Right? I know that one of those things has to be true in order for the product to be 0. All right, so where is the cosine of t equal to 0? All right, if I look at my unit circle, all right, look at my unit circle, cosine is the x-coordinate, right? So the x-coordinate is 0 here and here, right? And I'm looking for the values of t between 0 and 2 pi. So that's good. I don't have to, I can just use one cycle of the unit circle. So t is equal to pi over 2 and 3 pi over 2. Okay, those are the values of t that make cosine of t equal to 0. On this side, I need to do a little algebra. I'm going to add square root of 2 to both sides. So I get 2 sine of t is equal to the square root of 2. And then I can divide both sides by 2, and I get sine is equal to the square root of 2 over 2. Okay. So square root of 2 over 2. Now I know that that happens at 45 degrees, which is pi over 4. So at pi over 4, that is one of the solutions to my equation. So t equals pi over 4. But there may be others, right? So the sine is the y value. So I'm looking for other angles that have a positive square root 2 over 2 as the y value. And that's going to be here as well, straight across here. Now, this doesn't look very much like a 45 degree angle, but a 45 degree reference angle. But over here at 3 pi over 4, you can probably just look at your unit circle and see this right away. I have another case where the sine is a positive square root 2 over 2. So my other solution is 3 pi over 4. Okay? And those are all the solutions I have between 0 and 2 pi. So I'm done. I basically have these two, and I also have these two angles that satisfy this equation. All right, I will see you in the next video.